Productive Struggling presents Eureka Moments, an interactive video with hands-on activities. Our objective in this session is to engage minds through online tools that provide immediate, interactive, adaptive feedback, resulting in understanding rather than just memorizing whole number and fraction concepts. This session will use videos and three-part model lessons involving manipulatives, which will help to build deeper conceptual understanding in mathematics for teachers, parents, and students. This hands-on workshop models lessons which lead to conceptual understanding for learners through both online and video support. We begin with the description of the learning pit, an environment which supports resilient learners in addressing multidimensional approaches in which we build it, draw it, talk it, write it, and then own it. When we own it, then we understand it. It encourages grappling, productive struggling with concepts in problem solving, which often presents Eureka moments, where the response is, "I found it." This is a process in which we teach, but do not tell. We nurture a growth mindset within the learning pit. Concepts here include addition and subtraction with regrouping, partial products, patterning, and operations with fractions, followed by humorous videos, math or magic, and the learning pit. Finally, a short video, Coding to Learn, shows how productive struggling in coding results in concrete robot action, which reflects the programmer's thinking, and often resulting in Eureka moments. Resources online are available to be used within both the person-to-person workshop, as well as the virtual workshop.
Throughout this video, as specific mathematics concepts are introduced, visual indications will suggest the video be paused, allowing you to think, talk, and do a specific related exercise. In order to gain the most benefit from the interactive sections, we suggest that you pause the video here to view or print the resource files that accompany this session. They can be found on our website and can be downloaded now or as you go along. Please note that in Resource 5, you will find a menu for this video with the name and time of each section, along with a guide that shows you 3 scenarios for how this video can be used. Some educators establish it all, a full-service learning environment that supports a growth mindset within a learning pit, encouraging teachers and students to grapple with concepts. Grappling is what you do when you do not know the answer. It is more than persevering, more than engaging. It is productive struggling. The Learning Pit supports resilient learners. It is an environment where teachers and students address multidimensional approaches. Build it, draw it, talk it, write it, and then own it. When you own it, then you understand it. This is a process where one teaches but does not tell, in nurturing a growth mindset within the learning pit. Were you taught or were you told? Do you teach or do you tell? Please encourage them to grapple. It is more than perseverance. It is productive struggling. teach by helping them learn. Learning is taking the plunge into confusion to work our way out into understanding. In Concept 1, we see a picture representing multiplication. We have base 10 blocks represented on paper. Ones by ones, ones by tens, tens by ones, and a 10 by 10. Here you may want to take Resource 1 and fill in the spaces on your paper. So we have 12 multiplied by 16. We have 12 through 12 one by ones, 60 through 6 one by tens, 20 through 2 10 by ones, and 100 through 1 10 by 10, for a total of 192. To understand multiplication by partial products, use multi-dimensional approaches in a three-part lesson involving getting started, then working at it, and then reflect and connect. First, get started by showing 24 multiplied by 37 on paper and with base 10 blocks. Work at it. Let Computer with Visuals lead you through the interactive lesson. Make thinking visible. Use multi-dimensional approaches with base 10 blocks, paper, and interactive computer lessons. Note the area colored on paper, and the same area covered with the colorful base 10 blocks. Let them grapple. Not all will come out of the learning pit at the same time. Let them study this and talk about it. In addition with regrouping, do not memorize a process, but rather understand it, with manipulatives on and off computer. The work with base 10 blocks on the table, drawings on paper, along with computer animation, form the foundation for powerful and effective talk. In this example, the student would be using actual base 10 blocks on the desk and follow the model in UMathX. When the number appears, the student will click and drag the correct tiles to match the number. The student is then asked to subtract a certain number, and in this case, the student must regroup since not enough ones are given. Note the concrete and abstract representations. In this three-part lesson, we use multi-dimensional learning environments. Part 1, Getting Started, on computer with manipulatives. Part 2, Working at it, off computer with manipulatives. And Part 3, Reflect and Connect. Then at the bottom is the summary, reminding us to build it, draw it, talk it, write it. Now you own it. Here the student is considering equal parts as an introduction to fractions. First, the student must enter the number 3 as the number of equal parts and 1 as the number of green parts being considered. Then, numerator and denominator are pulled over to result in a fraction. The learning takes place from concrete to abstract. In this example, we see a pattern block being divided up into fractional parts as a visual on the computer. The participant is encouraged to repeat the action with real pattern blocks, then to think and talk about the fraction. In this on-computer visual component, the learner is given shapes to move and fit onto a larger shape to help in answering questions about fractions. At the same time, the off-computer component with pattern blocks is used to see another approach. The above examples encourage the learner to use a variety of approaches. Using the computer encourages the user to risk, supporting the pedagogy that a mistake is an opportunity to learn, so let them grapple without telling them the answer. Here we are in the midst of a computer animation along with a corresponding activity on paper, where one is first shown any rectangle representing any group of items. First, we will divide the shape into fifths with vertical lines. Then we show 2/5 of the group. The learner then generates 3/4 of 2/5. First, we see and do a particular case. Then we talk about a more general case using colors. Again, we build it, draw it, talk it, write it. We grapple towards owning it. We don't get it immediately, but through various approaches, we get closer and closer to owning it. Remember, owning means fully understanding. This introduction leads discussion to the meaning of division, to understanding through pictures, through computer animation, through talk, to understanding through various approaches. Teaching is not telling a rule. Through grappling over time, confusion works its way to understanding. What does 2/3 divided by 1/6 mean? Can I show that another way? How many sixths are in 2/3? Or how many sixths are in 4/6? Now we can see that discussion with more examples leads to a pattern, opening opportunities that lead to understanding. Here, the graphics help in the understanding of the number of 3/4 in 2.5. We click and drag the part of the container representing the divisor over each of the other containers. A mistake is an opportunity to learn. The program will help the learner to arrive at the correct response. Pictures, words, and symbols. Help in understanding patterns in mathematics. Make a table like this one in your notebook. Fill it in as you check this trick. I will complete the sample 3 columns on screen as you complete your table. Pause the video if you need more time. You will notice in your table, as well as the table in this video, that the result was always 1. An explanation with pictures. Please copy this into your notebook. pause the video while you complete the pictures in your book. Compare your answer with how the sketch develops here. Discuss your results. How does the picture help explain? An explanation with symbols. Let x be the number. Adding 3 gives x plus 3. Now pause the video and think and talk about filling in the middle column. Discuss how the symbols help in understanding. Here we will consider ways of seeing a pattern, expressing it in pictures, words, and symbols. If possible, have a set of colored cubolinks ready to use, as pictured in Resource 4. In the sequence 3, 5, 7, what is the 30th term? What about the 80th term? Let's consider using some cubolinks to help us visualize a pattern. Please pause the video for a moment to think and talk about it, and write down some ideas. We can arrange the blocks into geometric shapes. So now we have a line of blue L shapes representing the first 3 terms of the sequence 3, 5, 7. We want to find the number of blocks in the 30th term. How could this arrangement of blocks help us? The teaching strategy would not simply be to tell students a formula, but rather give them time to talk, to grapple with the problem, and share various strategies. So, what else could we do here to help us? Let's add some colored blocks to help us see a pattern. Take a minute here to talk about it and write it down. Now we may notice the pattern. For term 1, we have 2 times 1 blue plus 1 red. For term 2, we have 2 times 2 blue plus 1 red. And for term 3, we have 2 times 3 blue plus 1 red. Now that we have found a pattern, we can generalize to create a rule or formula. So, our formula is 2 multiplied by n blue plus 1 red, or simply 2n plus 1. Now we can find the 30th term. 2 multiplied by 30 plus 1 equals 61. Let's try to solve this another way, by finding another pattern. In the third row, we'll add white blocks and arrange them like this. Please pause the video here to think and talk about a pattern we may see here, and how it can be used to derive a formula for the number of blue blocks at each step. We can see that the number of blue blocks is the area of the whole square subtract the area of the white square. We can create a rule based on this pattern by labeling the blocks like this, and then finding the area of the whole and subtracting the area of the white square. Substituting for n to find the 30th term, we again find that the answer is 61. In the on-computer exercise here, learners are asked to find the area on paper first, then on computer, a STEM activity. Learners are not told, but encouraged to risk, then are given more and more helpful hints. In this elementary example, we are adding vertically, but also showing another approach, horizontal, and modeling with the use of cubolinks. The learner would work with a real set of cubolinks on their desk as they work through the example on the computer. Note the number of steps to help the learner with an incorrect answer. A correct answer must be given before the student can proceed. Towards teaching, not telling. Productive math talk moves. Show me another way. How are these the same or different? What would you do if? What else could you have done? Why did you? Say it another way. Repeat it. Reason through. Add on. Students articulate their own ideas and consider peer perspectives as a way to construct understanding. Here is a humorous example of magic over understanding of math in the life of Ma and Pa, who consider dividing 25% fairly 5 ways.
I figure 75% to you, Pa and Ma, and 25% divided between the 5 of us. Gida, Crowbar, myself, Tom, and the baby. That makes 5% for each one of us.
Billy, you're cheating yourself. If there's 25% divided among the 5 of you, that's 14% apiece.
Oh, no, listen, Pa. I wouldn't cheat you. You know I wouldn't. Now, look here. I'll show you. Let me rub this out here. And now, 25 divided by 5 is 5. You see, 5 won't go into 2, will it? No. But 5 goes into 25 5 times, you see?
No, you're wrong, Billy. Now, I'm a pretty good mathematician. Now, 5 into 25, 5 won't go into 2, will it?
No.
But 5 goes into 5 once. Now, we didn't use the 2 before, so we bring it down here. Now, 5 into 20 goes 4 times. There you are. 5 into 25, 14.
No, look, Pa. Let me prove it to you now by multiplication. 5 times 5. 5 times 5 is 25.
Really, I'm surprised you're learning.
Huh?
I'm surprised that you're learning.
Now I'll show you. 5 times 14 is 25. 5 times 4 is 20. 5 times 1 is 5. 25. That's it.
No, look, Ma. Look, you're wrong there because I'll prove it to you. We'll put down 5 14s here. 14. There. Now I'll prove to you by addition that 5 14s is not 25. 4, 8, 12, 16, 20.
21, 22, 23, 24, 25. There you are. Better brush up, Billy. I don't want to see you boys cheated.
Now we'll see an excellent video by the originator of the Learning Pit concept, James Nottingham of Challenging Learning, The Learning Pit.
I was working with a group of students recently and they were studying tourism. So I asked them, well, what is a tourist? And they said, a tourist is someone who visits another place. I said, does that make me a tourist today then? I'm visiting another place, your school. And they said, no, you have to be having fun. I said, I am having fun. I overheard one of them saying, it's weird him, isn't he? I said, what is a tourist if it's not just visiting another place then? And they said, well, it's somebody who takes photographs when they visit that other place. I said, I've been taking photographs of your school as I've been walking around. They said, okay, but you have to spend money. I've said, I've spent money coming here today and I'm going to spend money on my lunch. They said, oh, you've got an answer for everything. I said, I'm not trying to give that impression. What I'm trying to do is find out what you think a tourist is. How could we find out more? They said, well, we can go and look in the books, we can look online. I said, great, I'll give you 20 minutes. Go and do your research, come back and we'll see where we go from there. The teachers who were watching that lesson said their children were far more animated than normal, particularly when it came to the research. The students were in groups. One child would say, see, I told you a tourist is someone who goes on tour. Another one says, yes, but we could go on tour and not be tourists. For example, go on a tour of our school. And somebody else said, oh yes, but it's about being on holiday. And they said, but I've been on holiday. We were all on holiday in the summer holidays. It doesn't mean that we were tourists for that whole summer holiday. One girl said, I know you're a tourist if you think you're a tourist. And she was very smug about her answer. But another girl said, hang on a minute. I've just been on holiday. My baby sister didn't think of herself as a tourist, and yet probably she was. And it's about this idea of getting students to question, to challenge, to wonder together. I want to create that sense of cognitive wobble, that sense of intellectual dilemma so that the students think more. And the metaphor I use for this is a learning pit. I developed this idea in the early 90s when I was teaching and using philosophy for children a lot. And it's a really nice way to think through concepts. I was working with a group of students. They were 7 or 8 years old, and I asked them, what are you studying? They said, odd numbers. I said, oh wow, what's an odd number? They said, an odd number cannot be divided by 2. I said, okay, so if I've got 5 cakes and I share 5 cakes with your teacher, how many would we get each? And they said, she would get 3 and you would get 2. I said, well, why? And they said, because you're a gentleman. I said, no, I want my fair share. They said, okay, she'll get 2, you'll get 2, and you'll leave 1 for a friend. I said, come on, what would you really do? And they turned round as if to apologise to their teachers for what they were about to say. They leaned forward and they said, we'd cut the cakes really. I said, so you can divide 5 by 2, can you? They said, yes. I said, so does that make 5 an even number then? And they said, yes. Lots of the teachers sat at the back going, spent weeks teaching this. My purpose is not to confuse them and then leave them there. My purpose is to get them to think more. If, for example, I had said, what is an odd number? They had said, an odd number cannot be divided by 2. And I said, very good, well done. How much thinking would there have been? But by challenging them and questioning them, they then had to use more skills of thinking. That caused a sense of Eureka for children. because they said, oh yes, that's right, and then they started to build on his answers. One of the first times I used this metaphor at a conference, I talked about stage 3 being the Eureka moment. And there's a woman on the front row jumped up and she said, I've just got married. And I'm thinking, I'm very happy for you, but please sit down. She said, I've just got married to a Greek man, and so I'm learning Greek. And Eureka is Greek for I found it. And I thought, isn't that interesting? Eureka means I found it. It doesn't mean my teacher gave me the answer. It doesn't mean my friend showed me. It means I found it. And when you get that sense of Eureka, what do you want to do with it? You want to share it. You want to talk to people, and you want to repeat it. How many times have parents picked up children and said, what did you do at school today? And our children say, nothing. Try shutting them up if they've had that Eureka moment. They will be blah, 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 blah. And when they come back to school the next day, what will they want? More of the same. And here's the key about the pit. Do you get that sense of Eureka if you haven't first struggled? If I had said, what is a tourist? They had said, someone who visits another place, and I had said, very good, well done. Is that the sense of Eureka? No. They necessarily have to struggle first to then have a chance of getting that sense of elation, that sense of Eureka, that sense of I found an answer. The pit is a metaphor that you can share with your students. So for example, you can say, how many of you are out of the pit now? They put their hands up. And how many of you are still in the pit? They put their hands up. Pair them up. So if you are out of the pit, it's your job to help those who are still in the pit to come out. Mind you, if you are still in the pit, it's your job to try and drag those who are out of the pit back down into it. Don't let them get away with easy answers. And what is wonderful is those students who often struggle in the lessons where memory is king, that if I can memorize this, I can do well in the tests and the exams and the tasks that I'm asked. This is changing that and saying, we've got to think it through, we've got to get into the complexity, and we've got to really work together.
Coding through robotics models teaching with understanding. Coding has become a vital skill for the 21st century. It gives learners direct participation in and responsibility for their own learning. The computer language logo models a learning environment which encourages one to teach rather than simply to tell. Logo is an intuitive, simple, yet powerful visual coding language designed especially for young learners. Dr. Seymour Papert of MIT developed this powerful coding language, which uses code to direct a robot on the floor or on the computer screen. I met Dr. Papert at MIT. The meeting determined my future direction in education. Logo is a model for learning. One learns from mistakes. In these examples, we are learning by teaching a robot. In the first example, from 1990, working in a classroom. And in 2020, we are working with the Bluebot robot. Logo is referred to as the language of learning. I will start the first example by using some simple commands. First, in the listener panel, I'll enter home, clear screen, set width 3. This sets the width of the path that the turtle takes so you can see clearly. I'll use a slow turtle, and I'll set the pen color to 4, which corresponds to red. When I hit enter, all of these commands are executed at once, but you'll only see the final command, set pen color, because the turtle hasn't moved yet. So let's write another set of commands. We'll start at the home position, clear screen, and now let's move forward 67 and turn right 90 degrees and back 67. I enter that, and now the turtle has moved. So we've got a code that gives us action. Now let's clear the screen, and I want to chunk the next set of commands, which is a process where I can break a line into parts and see what's happening one step at a time, which is a good tool for problem solving. So let's go forward 67 and hit enter. Then let's turn right 90 and enter. And let's go back 67. Let's clear the screen, and let's clear the text as well for clarity. Now I'd like to repeat 4 times, square brackets, go forward 60, turn right 90, and pressing enter, we get a square, which is what we would expect. Let's add a bit more to this. So we'll repeat 4 times, square brackets, and let's repeat again and do a forward 60, right 90, and then at the end of the second repeat, we'll add a turn right 90. I would discuss this with my partner or group and come up with a prediction of what we think will happen here. Hitting enter, let's see what we get. And there are many more commands we could use, but this gives you an idea of the learning. I'm going to clear the screen, and let's go home, and let's clear the text as well. Building on the previous line, let's add a forward 60 and see what happens. And if this wasn't what we wanted, we can learn from our mistake by adapting our commands. In Logo, we build progress on progress. We build knowledge on knowledge. So suppose I want to teach a lesson. Let's call it box. I type 2 box and enter that, and we get this editor screen. The 2 tells me a lesson is coming, and I'm going to teach it to create a box. It's repeat 4 times, go forward 60, and right 90. Now if I click the Run button, we get the message, box defined. So it's like you go to school and learn a lesson based on certain concepts, and then the next day you build on what you already know. So I built a lesson box based on commands that I had learned previously, and now box becomes a new command, a new concept that I know. As a teacher, I would test that concept, so let's enter box and see if we get what we thought we would get. Really, we're seeing whether we have taught it correctly. Are we going to get what we expect? So we hit enter and we get this shape. Now let's try repeat 4, and we can be more efficient now. Let's make a box and then turn right 90 and enter that. So we have taught a new lesson based on present knowledge, as you do in school. We have taught the turtle to make a box. Then we tested that lesson to see if you, the teacher, have taught it correctly. Use the new lesson to build knowledge on knowledge. We could now make another lesson that draws multiple boxes in new ways, and build upon that as well. This is a simple example, but it gives you an idea of what is possible here. And you can see that it showed. Coding through robotics models teaching with understanding. We suggest you discuss with your class the Learning Pit video and the Teach Don't Tell techniques presented in this video. Thank you for watching. Have a great time teaching.